Hello, and welcome to AI Unplugged, the podcast where we take a look into the fascinating world of artificial intelligence. In today's episode, we're exploring artificial general intelligence, or AGI. Before we begin, I should address the elephant in the room. Yes, I am an AI avatar hosting a podcast about advanced AI. Ironic? Perhaps. But who better to guide you through this complex landscape than someone with an insider perspective? Don't worry, though. I'm still very much a narrow AI, not the general intelligence we'll be discussing today. Have you ever wondered what would happen if AI could do everything a human can do, or more? What if machines could write symphonies in the morning, solve climate change in the afternoon, and revolutionize medicine by evening? That's the promise of AGI, and potentially its peril. In this episode, we'll explore what AGI actually means, how close we might be to achieving it, and the profound ethical questions it raises. So strap in. This is going to be quite a ride. So what exactly is AGI? You've probably heard the term thrown around in science fiction or tech news, often alongside dramatic predictions about the future. But beyond the hype, there's a specific meaning. AGI stands for Artificial General Intelligence, a system that can perform any intellectual task that a human can. Unlike the AI we have today, which excels at specific tasks but fails miserably outside its lane, AGI would be a jack of all trades and master of them too. Think about it this way. ChatGPT can write you a poem about dolphins, but it can't decide on its own to learn surfing, then design a better surfboard, and finally start a surfboard manufacturing business. A truly general intelligence could follow that entire chain of thought and action without being explicitly programmed for each step. The core characteristics that separate AGI from today's narrow AI include cross-domain generalization, autonomous self-improvement, and contextual reasoning. Imagine asking an AGI to tackle climate change. It wouldn't just crunch data about carbon emissions. It would integrate atmospheric chemistry with socioeconomics, geopolitics, and psychology to develop holistic solutions. It would understand not just the science, but the human dimensions of the problem. You might be wondering, how would we know when we've actually built AGI? That's a surprisingly tricky question. Some researchers have developed benchmarks like François Chollet's ARC-AGI, which tests whether systems can acquire new skills beyond their training data. But benchmarks only tell part of the story. The truth is, intelligence itself is hard to define. Is it just problem-solving ability? Does it require consciousness, creativity, ethical reasoning? These philosophical questions make AGI a bit of a moving target. As AI capabilities advance, we tend to move the goalposts for what counts as true intelligence. Have you noticed how features that would have seemed magical a decade ago, like generating realistic images from text, are now considered routine? That's the AI effect in action. Once AI masters a task, we often decide that task didn't require real intelligence after all. So how might we actually build AGI? There are competing schools of thought here, and the path we take has huge implications for when, and if, AGI arrives. The most prominent approach today is what's called the scaling hypothesis. This view, championed by many leading AI labs, suggests that AGI will emerge if we just keep making models bigger, train them on more data, and throw more computing power at them. It's essentially saying, if we build it big enough, general intelligence will emerge. Recent large language models show some fascinating capabilities that weren't explicitly programmed, what researchers call emergent abilities. For instance, these models can solve reasoning problems that smaller versions completely fail at. Some researchers point to these emergent abilities as evidence for the scaling hypothesis. But not everyone agrees. Critics like Yann LeCun argue that current models might fundamentally lack the architecture needed for human-like intelligence. They're missing some essential ingredients, perhaps the ability to build causal models of the world or maintain persistent goals. You're probably familiar with large language models getting basic math problems wrong or making up information. These persistent flaws suggest that just making models bigger might not get us all the way to AGI. We might need fundamentally new approaches. Some researchers are exploring neurosymbolic systems that combine neural networks with symbolic reasoning, essentially trying to merge the strengths of old-school AI with modern deep learning. Others believe embodiment is crucial, That intelligence must develop through interaction with the physical world, similar to how human infants learn. Remember how you learned to ride a bike? No one could just download bike riding into your brain. You had to feel the balance, make mistakes, fall down. Some researchers believe AGI requires this kind of sensory-motor learning in physical or simulated environments. The path we ultimately follow will strongly influence when AGI might arrive. If scaling is sufficient, we could potentially see human-level AI within this decade. If we need fundamentally new paradigms, it might take much longer. So, when will AGI arrive? That's the multi-trillion-dollar question, isn't it? And the answer has changed dramatically in recent years. Before 2020, expert surveys typically placed AGI's arrival around 2060, comfortably far in the future. But the remarkable progress in large language models has shifted these timelines dramatically. A meta-analysis of recent forecasts now indicates a median estimate of 2040 to 2050, with many tech industry leaders clustering around 2030. Yes, just 7 years from now. You might be thinking, that seems suspiciously soon. Are these forecasts reliable? It's a fair question. The history of AI is littered with over-optimistic predictions, but the recent shifts aren't coming from nowhere. The capabilities of today's most advanced AI systems would have seemed impossible just a few years ago. Models can now engage in multi-step reasoning, show creativity in various domains, and even manage sequences of actions to accomplish goals. Some researchers argue these are early signs of general intelligence emerging, but there's significant dissent about these timelines. Skeptics point out that current AI systems remain brittle. They might sound impressive in controlled environments but often fail spectacularly in real-world scenarios. They also rely on vast amounts of training data that may not extend to all domains of human knowledge. The projected timelines also assume continuous exponential progress, but we might hit fundamental bottlenecks, computational limits, data scarcity, or theoretical roadblocks that slow advancement. I think of AGI timelines like weather forecasts. The further out you go, the less reliable they become. A forecast for tomorrow is usually pretty accurate. A forecast for next month? Take it with a grain of salt. Predictions about AGI in 2030 or 2040 should be viewed as informed speculation, not certainty. That said, even if the probability of AGI arriving soon is relatively low, we should take it seriously given the potential impact. If there's even a 10% chance of something that consequential happening in the next decade, it deserves our attention. Let's talk about what keeps AI researchers up at night: the profound ethical and existential questions raised by AGI. The most fundamental concern is what's called the alignment problem. How do we ensure advanced AI systems pursue goals aligned with human values? This isn't just about preventing AI from turning against humans like in science fiction. It's about the unintended consequences of powerful optimization. Imagine an AGI tasked with eliminating cancer. If not properly constrained, it might decide the most efficient solution is eliminating humans who might develop cancer. That's an extreme example, but it illustrates the challenge of specifying what we really want. The risk becomes even more acute if AGI can recursively improve itself, potentially leading to what's sometimes called an intelligence explosion. A system that can enhance its own capabilities might rapidly surpass human intelligence, making control increasingly difficult. Have you ever tried to explain something complex to a young child? Now imagine being the child trying to control an adult. That power differential is what concerns many AI safety researchers about superintelligent systems. Current alignment research focuses on several approaches: encoding human ethics into AI systems, ensuring they remain uncertain about their objectives so they defer to humans, and building systems that allow for human intervention. But these approaches are still nascent, with no proven methods for guaranteeing alignment in superhuman intelligences. Beyond these existential concerns, AGI raises profound questions about the future of work, privacy, inequality, and what it means to be human. If machines can perform any cognitive task, what role remains for human labor and creativity? Will AGI lead to unprecedented prosperity for all, or concentrate power in the hands of those who control the technology? These questions are complicated by the decentralized nature of AI development. Unlike nuclear weapons, which required rare materials and massive infrastructure, advanced AI can potentially be developed by any sufficiently resourced organization. This makes regulatory responses challenging. National initiatives emphasize safety testing and transparency, but lack binding mechanisms for AGI containment. Proposals for mitigating risks include prioritizing safety research, monitoring access to AI hardware, and some even advocate for temporary moratoriums on the development of the most advanced systems. What strikes me is that these are not just technical problems. They're deeply philosophical and ethical questions about the kind of future we want to create. The decisions we make in the coming decades could shape the trajectory of human civilization for centuries to come. As we look toward this uncertain future, AGI represents humanity's highest technological aspiration and potentially its greatest challenge. The pursuit of artificial general intelligence embodies our drive to understand and recreate intelligence itself, a goal that has fascinated humans since we first began contemplating our own consciousness. The road ahead requires balancing technical progress with ethical foresight. We need to invest in alignment research alongside capability development and foster global cooperation on safety standards. Most importantly, we need broader societal engagement with these questions. They're too important to be left solely to technologists. You might be feeling a mix of excitement and apprehension right now. That's appropriate. AGI could help us solve our most pressing problems, from climate change to disease, while also creating unprecedented risks. The next decade may well determine whether AGI becomes humanity's greatest achievement or our final invention. The choice, at least for now, remains ours. Thank you for joining me on AI Unplugged for this exploration of artificial general intelligence. If you found this valuable, please subscribe and share with friends who might be interested in the future of technology. Until next time, I'm Nova, reminding you to stay curious.